Hello, Honors Chem students. Mr. Keister here with you again. And today, this is the video for Thursday, September 17th, 2020, which is our scheduled 20th day of school for the fall semester. Always keep in mind, though, that the dates could change for a variety of reasons, but the order of the lessons will remain the same regardless. So, let's look at today's schedule. Now. So we have a short lab for you to do today that kind of ties together measuring and significant figures and rounding and all that good stuff. Lab 1-3, the density of aluminum foil, which is page 31. And from yesterday, you had a proportional reasoning assignment, and I also handed out the review for the test, exam 1-2 review. So you should have already been working on that. Hopefully you have it done. So your homework for today was the proportional reasoning assignment. I am not collecting that, but please check your answers. They are posted both on the backboard and online on my answer key page. Make sure that you know how to do everything regarding proportional reasoning, because you are going to see some on exam. Today you're going to complete lab 1-3. Again, shouldn't take the whole period. That is due today, by the way, by the end of the period. So you are to turn that in today. Of course, if you're home, you watch the video and then turn it in today as well. With whatever time you have remaining, once you've done that, you can continue to work on your exam review, or if you have it finished, let me see it, and you can check your work today before you leave. Otherwise, that review answer key will be posted tomorrow by 7 a.m., both here and in Canvas. I will be collecting the review tomorrow during your test. So tomorrow we have a test in school, all right, on campus here. And so, and I mentioned this before, the procedure for that is, even though the exam review is technically due today, I don't collect them until test day. So tomorrow when you come in the room, you hand me your review, have it ready. It'll save you a minute. Might need that minute. Have it ready, hand it to me, I'll hand you a test, and away you go, and you can start taking your exam as soon as you sit down, as far as I'm concerned. So if you get here a few minutes early, you get a few more minutes to take the test. Okay? You have a mastering assignment that is due tomorrow morning at 7:30, so that's on the agenda as well. Hopefully you've already been working on that this week and maybe already have it finished. So let me advance the page here. Again, exam 1-2 will be tomorrow. The review list I've already posted in Canvas, so it's already there. Topics that will be covered include a review of Unit 1-1 topics that would include extensive intensive properties, recognizing reactants and products in a reaction, recording a measurement properly, knowing the rules of sig figs, and how to round a calculation properly based on either precision level or sig figs, whichever is called for, and also recognizing and drawing different types of particle diagrams. All that is reviewed from 1-1, stuff that you still need to know, obviously. In addition, new topics from 1-2 include being able to define and recognize both accuracy and precision, and then calculations involving mass, volume, density, specific gravity, and knowing when mass and volume can be recorded directly or indirectly. We talked about that. And also percent error. The equations and constants that you will need for the exam will be on the exam. You won't have to memorize any equations or constants. Recognizing similarities and differences in mass, volume, and density from a particle diagram. You should be able to determine that. We've gone over that. Knowing how to compare and contrast pre-1982 and post-1982 pennies. Let's see, lab activity 1-2 part C involved penny density. I think I would look that over. Reading and analyzing a mass versus volume graph. We spent a lot of time doing that. Being able to complete conversions involving both conversion factors and dimensional analysis, and proportional reasoning, both methods. You will be tested over both of those methods. You still need to know the metric prefixes from Unit 1-1. Not only then, not only now, but on into the future too. They will show up on this test and many others. And finally, on all math-related problems, don't forget that right there. Don't let that bite you on the test, please. Counts more. Show all equations and or the method you use to solve your problem. Make sure you write down the numbers. Write down the equation if used. Show all work. Label conversion factors or proportions on those. Make sure you label them with the correct unit. Round correctly everywhere you're supposed to, or don't round where you're not supposed to. And we've talked about that many times too. And then make sure you label and round your final answer correctly. All of that will be on the test tomorrow. So make sure you look over your review assignment, your notes, absolutely your notes, and any assignments, lab activities, etc. that we've done that involve these topics right here. Okay? All right. Having said that, let's head back to the lab area and we'll do a quick run through of lab 1-3. Here and back we'll go. Set this up here. Need to go grab my calculator, so I will be right back. Just give me a few seconds. All right. I was gone so long you could have went and got a snack. Maybe you did. All right. So this is lab 1-3 right here. And our objectives are to correctly apply the principles of significant figures in both measuring and calculating the thickness of aluminum foil, to apply the rules of problem solving and incorporating data and equations, and to apply the acquired knowledge of both of those things to a real-life application, which is what the back of this lab will do. So we're going to determine the thickness of a piece of aluminum foil by understanding how it relates to density, okay? So here's a piece of aluminum foil. Looks like a regular shape, rectangular. I can measure length and width fairly easily, but measuring the thickness is another issue altogether. It's too thin, all right? Can't use a ruler to measure that. So since that, we don't really have a device available to us that could do that, then we're going to determine its thickness by understanding the relationship between mass, volume, and density. And remember that volume of a regular solid involves length, width, and height. In this case, height would be thickness. So our procedure, we're going to use a centimeter ruler and measure the length and width of one piece, each of regular and heavy aluminum foil, measured in centimeters, and record. So I am going to measure, this is regular aluminum foil, standard foil, and its length. And again, with a centimeter ruler, we're looking at the smallest marking value of the 0.1 centimeters. So we're going to have to go one past that to the 0.01, or 2 decimal places. And as I measure the length here, looks to be right on a line. 19.10 centimeters, 19.10. And if I do its width, well, looks like it's right in between 14.9 and 15.0. So I'm going to go 14.95 centimeters for its width. And then we need its mass. So let's just do that real quick. We'll put that right there on the balance. And its mass is 1.23 grams. 1.23. Here we go. All right. Now we'll do the heavy. Okay, so when you buy heavy duty aluminum foil, of course it doesn't tear as easily because it is thicker. And we're going, most of this, maybe wrap our turkeys with it or some other type thing when we're cooking or baking. And so it doesn't tear as easily, and so it's more heavy duty. Costs a little more too. So we're going to do the same thing with this piece. About the same size as the other one, very similar. The length is 19.20 centimeters. 19.20. Its width is 15. Let's see. It's about halfway between 0.3 and 0.4. 15.35 centimeters. And the mass of this heavy-duty aluminum foil, 1.85 grams. 1.85. All right. So we've recorded all our measurements to the correct precision level, and we have hopefully labeled them. I know I did. I hope you did as well. Calculations. Using the data obtained above plus the following information, find the thickness of each piece of foil. Okay, well, let's talk about that, shall we? Let's see. Where do I got a spot? Let's go back up to the front, and we will do that. Need a little board room here. Which I have right over here on the side. Let's see. Yeah, that'll work. All right, so here's what I want you to understand, how we can relate this stuff together so we can figure out the thickness of this foil. I'll look at one of them for you and get you started on it. So I'll just do my work down here below, right down here where we have room down there. So this is for the regular. So first of all, we know the relationship between mass, volume, and density, of course. We've been working on that most of this unit. So D is M over B. All right. We have our density, 2.70. That's the density of aluminum, which is given to us. And for the regular piece of foil, the mass was 1.23 grams over B. All right. So if we could put a 1 underneath there, which then allows us to cross multiply and divide. So we have 1.23 equals 2.70 B. And if we divide then by 2.70, we will get the volume of the aluminum foil in centimeters cubed, right? This is 2.70 grams per centimeters cubed. The mass, of course, is in grams, so our volume would be in centimeters cubed. Now, you can do the math and calculate that answer. Make sure you record it to the proper number of sig figs. All right. So, in fact, no, we won't, because that's an intermediate calculation. So we're going to have a long answer there. So never mind. All right. My bad. Now we want to find the thickness. Well, here's where you got to recognize that the volume of this aluminum foil is equal, since it's a regular shaped solid, is length times width times height. So volume then equals length times width times height. We have the volume right here. So whatever you calculate, again, long answer, no rounding. Whatever you got there is going to go right there for your volume. So we have that number now, and we've got the length and width, 19.10, 14.95, and the height, or the thickness, Remember, height is thickness. So we'll multiply these two numbers together, okay, and divide both sides by that number. And those two numbers multiplied I have as 285.545. That all goes away, and the height then will be in so many centimeters. Here is where you're going to round it. This is our final answer, the thickness of our regular aluminum foil, which goes in the blank right up there above there, in centimeters. Now again, based on the data that we have here to work with, look up at your data table. And since we're multiplying and dividing, we're going to round by sig figs. So you will round your final answer here to the appropriate number of sig figs. Again, that's determined by your data. So make sure you look up there. So our intermediate answer here, remember, remains unrounded. That was our volume. Our final answer, our height or thickness, will be rounded appropriately. You will then repeat the same process for the heavy foil. Okay? So now, before I let you go, so you can finish, let's look at the back side of that paper. There are some questions and problems very much related to this one. Could this method be used in the lab, also be used to calculate the thickness of an oil spill? So if they spill oil, of course, oil is less dense than water, so it floats on the surface, right? So could you calculate the thickness of aluminum foil in a similar method that we here calculated the thickness of a piece of aluminum foil, right? So could you do it? Seems like a similar situation. So yes or no, maybe, whatever. If you could, what information would you need? Think about the information we utilized here to calculate the thickness of aluminum foil and relate that to the very similar situation of calculating the thickness of oil sitting on the surface of the water. All right? Think about the information you would need. What data would you have to collect to do that? Then in problems 2 and 3, these are very similar. Well, let's read 2. By mistake, a quart of motor oil was dumped into a swimming pool. Nice. I have a feeling that wasn't a mistake. It was probably a prank. That measures 30.0 meters long by 25.0 meters wide. How thick was the resulting oil slick? So here we go. Here's an oil slick in a pool. All right. So maybe we can calculate an oil thickness of oil on a body of water. It says a quart of oil is 943 centimeters cubed. Those two volumes are equal. So we dumped a quart of motor oil in the pool, so we dumped 943 centimeters cubed. All right. We have the length and width of the pool, which would be the length and width of the oil spill. All right. So, because it's going to spread out to cover the entire area of the pool, surface area of the pool. Notice, though, that that length and width is in meters. Our volume of oil is in centimeters cubed. So, then the units have to match. So, you're going to have to convert those length and width in meters into centimeters before moving on. Once you do that, the process would be very similar to what we did with the thickness of aluminum foil. If you've got the volume and you've got the length and the width, you should be able to get the height, right? Or the thickness. Number 3 is also a very similar problem, right? A little bit different scenario. But what it's trying to do here is utilize what we did with the aluminum foil and then relate it to some, everyday type situations where a very similar problem exists, and we could solve it in a very similar way. So, I believe that takes care of today. So, you are to complete the lab report and turn it in by the end of class today if you are here in school, or if you're at home, you're to watch the video and complete the report and submit it to me electronically before the end of the day today as well. So, until next time, this is Mr. Keister signing off. remember that you have an exam tomorrow. Make sure that you are prepared for it. All right. And until then, stay safe, keep working hard, focus, and I'll see you next time. Take care.